All right, we're taking a look at the quiz review for solving systems of equations with elimination. So we're going to use elimination to solve each system of equations. So taking a look at this first one, we have x minus y equals 2 and x plus y equals negative 3. So the goal of elimination is to get rid of one of the variables when you add the equations together. And if you get one of one variable, you can then solve for the remaining variable. So I want to first look for a strategy of how to do that. So in this one, I look at my x's, and I have 1x and 1x, which have the same coefficient of 1, but they're not the opposite sign, so they won't cancel. But I do have a negative y and a positive y, which will cancel, and I don't have to do anything, I don't have to do anything else to get those to cancel. So I'm good to go ahead and add these two equations together, and I'm going to just combine like terms. So I have 1x plus 1x, which is 2x. Here I have negative y plus y. These will cancel. And this equals 2 plus negative 3, or 2 minus 3, which is negative 1. So when I divide both sides by 2, I get x equals negative 1/2. So that is my value for x. Now I can take this x value and I can plug it back into one of the original equations, and I can solve for y. So I'll go ahead and plug it into this first equation here. So in place of x, I'm going to put negative 1/2 minus y equals 2. So I want to add 1/2 to both sides. So I get negative y equals 2 plus 1/2. That's 2.5, or 5/2. And then I can divide both sides by negative 1, which will give me y equals negative 5/2. So that's my value for y, and I want to write my answer as an ordered pair. So I have, negative 1/2, comma, negative 5/2. And that is my final answer on number 1. All right, I'm going to take a look at number 2. Once again, I kind of want to get a strategy before I start. My goal is to eliminate a variable. So if I look at the m's, I have 3m and 3m. Right now they won't cancel out because they're not opposite signs. With the n's, I have negative 4n and positive 2n's. They have opposite signs, but they don't have the same number, so they won't actually cancel. So I'll probably deal with my 3's and try and eliminate that way, but I do need to multiply one equation by negative 1 so that I can change one of them from a positive to a negative. So I'm going to multiply this entire bottom equation by negative 1, which means I need to rewrite everything. And so I get 3m minus 4n equals negative 14. And when I distribute the negative 1, I get negative 3m minus 2n, and then negative 1 times negative 2 is a positive 2. So now I'm ready to add these equations together. So 3m minus 3m cancels. Negative 4n minus 2n, they both have a negative sign, so I'm going to keep the negative and add these numbers together. So I get negative 6n equals negative 14 plus 2 is negative 12. Now I can divide both sides by negative 6, and I'm left with n equals positive 2. Now that I've solved for one variable, I can plug this into either equation and solve for the other. So I'm going to put it in here, and so everything else copies down. 3m plus 2 times 2 equals negative 2. So I have 3m plus 4 equals negative 2. I'm going to subtract 4 from both sides. I get 3m equals negative 6. And I divide both sides by 3 to get m equals negative 2. So when I put these in as an ordered pair, if I'm going in alphabetical order, I would do m comma n. So negative 2 comma 2 would be my answer here. All right, number 3. It says 3a plus b equals 1 and a plus b equals 3. So once again, I'm looking for a variable to eliminate. When I look at the a's, I have 3a and 1a. they don't have opposite signs and they don't have the same coefficient, so I'll look at the b's. Here I have 1b and 1b. So these are the ones I'll eliminate, but I can't eliminate them yet because they have the same sign. So I'm going to multiply one equation by -1 so that they'll cancel. So I'll go ahead and multiply the second equation by -1 and rewrite. So the top equation will stay the same, 3a plus b equals 1. The second equation, I'll distribute this -1. So -1 times a is -a, -1 times b is -b, and -1 times 3 is -3. Now I can add these equations together. So 3a minus 1a is 2a, b minus b cancels, and 1 minus 3 is -2. When I divide both sides by 2, I get a equals -1. Now I'm going to take that a value and I'm going to plug it into an equation. I'll pick this one. So I'm going to plug in -1 plus b equals 3. I'm going to add 1 to both sides, and I get b equals 4. And then I can express my answer as a ordered pair. In alphabetical order, I would have -1, 4. Okay, moving on to number 4. I have x minus 3y equals 11 and 2x minus 3y equals 16. So right away, I notice that I have two -3y's. Those will cancel if I multiply one equation by -1 to make it positive. So I'll go ahead and multiply the second one by -1 and rewrite them both. So I get x minus 3y equals 11. -1 times 2x is -2x. -1 times -3y is positive 3y. And -1 times 16 is -16. So now I'm going to go ahead and add 1x minus 2x is -x, -3y plus 3y, they cancel. So -x equals 11 minus 16 is -5. When I divide both sides by -1, I get x equals +5. Now I'm going to take that value and plug it in. I'll go ahead and plug it in here. So I have 5 minus 3y equals 11. I'm going to subtract 5 from both sides. So I get -3y equals 11 minus 5 is 6. So I divide by -3. And I get y equals -2. Then I'll write my answer as x comma y, so 5 comma -2. All right, moving on to number 5. Trying to find a variable that cannot be eliminated. So I've got a 6x and a 4x and a -3y and a -3y. I'll go ahead and cancel out the 3y's, but they have the same sign, so I need to multiply one equation by -1. I'll work with the second equation. I've done this a lot now, so should be getting the hang of it. I'm going to rewrite the top as is. 6x minus 3y equals 12. And the second one I will distribute. -1 times 4x is -4x. -1 times 3y is positive 3y. -1 times 24 is a -24. I'm going to add these together. 6x minus 4x is 2x. -3y plus 3y cancels. And 12 minus 24 is -12. When I divide both sides by 2, I get x equals -6. I'm going to go ahead and plug in that value right here. So I get 4 times -6 equals, or sorry, not equals, minus 3y equals 24. 4 times -6 is -24 minus 3y equals 24. I'm going to add 24 to both sides. -3y equals, this is 48. Divide by -3, and I get y equals 48 divided by 3 is -16. All right, so my final answer here is -6 comma -16. Moving on to number 6. want to figure out which variable to eliminate. I have 3x and I have x, and I have negative 4y and 3y. So this one seems to be a little tricky because neither variable have the same coefficient. And I actually can't multiply. Here I have a 1x. Oh, sorry. You want to figure out how you can make one equal the other. The good news is I can multiply 1x to be 3x. I can multiply 1 by 3, but also this is a positive 3x, so I want this to be a negative 3x. So what I'm going to do is multiply this equation by a negative 3 so that the x's will cancel out. So I'm going to multiply everything here by a negative 3 and rewrite. The top will stay exactly the same. 3x minus 4y equals negative 4. And here we have negative 3 times 1, which is negative 3x. Negative 3 times 3y is negative 9y. And negative 3 times negative 10 is a positive 30. I'm going to add these together. 3x minus 3x cancels. Negative 4y minus 9 will give me negative 13y. And then I have it equals 30 minus 4 is 26. So I'm going to divide both sides by negative 13. And I get y equals negative 2. All right, now I can just plug that value in to one of these equations. I'll go ahead and plug it in here. So I have x plus 3 times negative 2 equals negative 10. So x minus 6 equals negative 10. I'm going to add 6 to both sides, and I get x equals negative 4. I'm going to write this as a point, which would be negative 4 comma negative 2. All right. Moving on to number 7, I have 4x minus y equals 9, and 5x plus 2y equals 8. So 4 and 5 are not the same, and I can't do much to the 4 to make, I can't do anything to the 4 to make it turn into a 5. I have negative y and 2y. So they're already opposite signs, they're just not the opposite coefficient. So I can actually multiply this top equation by 2, and this will turn into a negative 2, which is what I want. So I'll rewrite both. This top one I'll distribute. 2 times 4 is 8x. 2 times negative y is negative 2y. And 2 times 9 is 18. Then I have 5x plus 2y equals 8. I'll add these together. I have 8x plus 5x, which is 13x, I believe. 2y, negative 2y plus 2y cancels, and 18 plus 8 is 26. When I divide both sides by 13, I get x equals 2. Now I'm going to use that and plug it back in right here. So I have 4 times 2 minus y equals 9. 8 minus y equals 9. Minus 8 from both sides. Negative y equals negative 1. Divide by negative 1, and you get y equals positive 1. So my final solution to this one is 2, 1. I want to make sure that is correct, because I believe I got a different answer last time. When I plugged this in, 4 times 2 minus y, 4 times 2 is 8 minus y, 9 minus, oh, there's my mistake. Okay, 9 minus 8 isn't negative 1. I'm going to back up here. Okay. 9 minus 8 is a positive 1, so if negative y equals positive 1, divide by negative 1, and I get y equals negative 1. There we go. So I'm going to plug that in here, 2, negative 1. All right. Checking number 8, we have 4x plus 2y and negative 2x minus 4y. So we've got a 4x and a 2x. and a 2y, and a 4y. So nothing can cancel out immediately, and actually both variables are equally easy to cancel out. Here we have a 4 and a negative 2, and here we have a 2 and a negative 4. So I could multiply the bottom equation by 2 to get a negative 4, which will cancel out the x's, or I can multiply the top equation by 2 to get a 4y, which will cancel with the y's. So I'll go ahead and do that. So I'm going to multiply the top equation just by 2. So I get 2 times 4 is 8x. 2 times 2y is 4y. And then 2 times negative 5 is a negative 10. On the bottom, I just rewrite. So I have 8x minus 2x, which is 6x. 4y minus 4y cancels. And negative 10 plus 1 is negative 9. So I'm going to divide both sides by 6. So x equals, well, 9 and 6 are both divisible by 3. So if I divide both the top and bottom by 3, negative 9 divided by 3 is negative 3. And 6 divided by 3 is 2. So I get negative 3 halves. So I'm going to plug in negative 3 halves for x. Go ahead and put it in here. So I have 4 times negative 3 over 2 plus 2y equals negative 5. So when I multiply fractions, I'm going to do 4 times negative 3, which is negative 12, and then I divide by 2. So negative 12 divided by 2 is negative 6, plus 2y equals negative 5. I'm going to add 6 to both sides, and I get 2y equals 1. And I divide both sides by 2, and I get y equals 1/2. So my final answer here is negative 3/2, comma 1/2. Okay, so that's all for the skills practice page on the quiz review. So I'm going to move on to the word problems that are on the back of this page. Okay. So number 9 says, Rema is older than Ken, the difference of their ages is 12, and the sum of their ages is 50. Find the age of each. So we have two people, Rema and Ken, and it's giving us information about their ages. So the difference of their ages is 12. Well, we've got to know what the word difference means. In math, if we're finding the difference, we're subtracting. So the difference of their ages is 12. Who am I talking about? I'm talking about Rema, who I can call R. Her age is R, and Ken, I can call his age K. So if the difference of their ages is 12, I can say R minus K equals 12. And that's my first equation. Then it's telling me that the sum of their ages is 50. Well, sum in math means plus. So the sum of their ages is 50, meaning that if I add their ages together, I will get 50. So if I'm solving for two things, which in this case I am solving for the age of Rema and the age of Ken, I need two equations to solve that, and I have two equations. And this is actually nice because it's already set up really well for elimination, because these K's will cancel each other out when I add these equations together. So I'm going to go ahead and do that. I have 1R plus 1R, which is 2R. Negative K plus K cancels. And then 12 plus 50 is 62. So I divide by both sides by 2, and I get R equals 31. Now that I have R, which in the context of this problem is Rema's age, I can now find Ken's age by plugging 31 into another equation, one of the original equations. So if Rema is 31, I can plug that in here. So 31 plus K equals 50, because the sum of their ages is 50. So I can find Ken's age by subtracting 31 from both sides. And we get that Ken is 19. So for word problems, rather than writing our answer here as an ordered pair, that doesn't really make a lot of sense. It's asking us to find the age of each, so I'm just going to write my answer. Rema is 31 years old, right here, and Ken is 19, right here. And that's all for number 9. So I'm going to look at number 10. Number 10 says, to save money for college, Roberto is working 2 part-time jobs. He tutors geometry students and delivers pizza. For 5 hours of tutoring and 3 hours of pizza delivery, he earns $167. For 3 hours of tutoring and 1 hour of pizza delivery, he earns $89. What is Roberto's hourly rate for each job? So I'm given quite a bit of information here. He has 2 jobs, and it's giving me different combinations of work and the amount of money he makes for each one. So for 5 hours of tutoring and 3 hours of pizza delivery, he makes $167. So I could represent this in an equation if I let T stand for tutoring, the hours of, or the amount he makes tutoring, and if I let P stand for the amount of money he makes delivering pizza, then the equation 5T, this would be 5 hours times T dollars, that's how much money he's making tutoring, if he does it for 5 hours, plus 3P, 3 hours times his hourly rate for the pizza, that equals $167. So this is equation 1. Then I'm given more information. I'm told that for 3 hours of tutoring and 1 hour of pizza delivery, he earns $89. So in the same way, I'm going to write the second equation. So this time he has 3 hours of tutoring and 1 hour of pizza delivery, and he earns only $89, which makes sense because he's doing less work. So my goal here is to solve for T and P, which is his hourly rate for each job, what I'm being asked to solve for. So if I'm trying to use elimination, I'm trying to find a variable that I can get rid of. Neither T nor P have matching coefficients, but if I look at the P's, I have a 3 and a 1. I can easily turn that 1 into a 3, and I actually want it to be a -3, so it'll cancel with the P in the top equation. So I'm going to multiply this by -1 and rewrite both. So I have 5T plus 3P equals 167. And down here I have -3T minus P equals -89. And I'm going to add these 2 equations together. So I get 5 minus 3 is 2T. Whoops, I made a mistake. I need to go back. I needed to multiply the bottom equation not by a -1, but by a -3. So I'm going to back up to here. And this actually needs to be a -3, and I'll try that again. So if you do something silly like that, don't keep going. You need to go back and fix your mistake. Otherwise, you're going to do a lot of work and then realize you have to start all over again. So -3 times 3 is -9T. -3 times 1 is -3, which is what I want. And then I need -3 times 89, which is -267. That's better. Okay. Now I'm ready to add these equations. So 5 minus 9 is -4T. 3P minus 3P cancels, what I want. And then I have 167 plus -267. So I have equals -100. When I divide both sides by -4, I'm going to get that T equals positive 25. So what's that mean in context of the problem? Well, T is his hourly rate for tutoring. So I still need to find his hourly rate for pizza delivery. So I can just take T equals 25 and plug it in, and I will plug it in right here. So I have 3 times 25 plus P equals 89. So 3 times 25 is 75 plus P equals 89. If I subtract 75 from both sides, I'm left with P equals 89 minus 75 is 14. So once again, it doesn't really make sense to answer this as a coordinate, but rather to answer the question. So what is his hourly rate for each job? We would say Roberto makes $25 an hour. This is for tutoring. And he makes $14 an hour delivering pizza. All right, so we're done with number 10. One more to go. So this one says, at the office supply store, 8 notebooks and 7 pencils cost $3.37, while 5 notebooks and 11 pencils cost $3.10. What is the cost for each notebook and each pencil? This problem is going to be set up really similar to the one above. So I'm given kind of two situations. You're buying 8 notebooks and 7 pencils for this amount, and you're buying 5 notebooks and 11 pencils for this amount. So that's our two equations. Equation number 1 is 8, I'll call notebooks N and pencils P. You have 8N plus 7P for 337. And secondly, you have 5N plus 11P equals 310. So we're going to try and solve for N and P. I'll try and use elimination here. I don't really have any nice numbers. 5 can't multiply to 8, 7 can't multiply to 11, so this is one where I'm going to have to multiply both equations. I'm going to get rid of the N, so that means that I need to multiply the top equation by, I could multiply the top equation by a -5, and I can multiply the bottom equation by 8. My goal being to cancel out the n's by getting a -40 up here and a +40 down here. So I'm going to distribute -5 times 8 is -40, n. -5 times 7 is a -35, p. And -5 times 337 is -1685. Down here, 8 times 5 is a +40n, which is what I want. 8 times 11 is a +88p equals 8 times 310 is 2480. All right, now I can add these together and my variable will cancel. So -40 plus 40 cancels. -35 plus 88 is 53p, which equals -1685 plus 2480 gives me 795. If I divide both sides by 53, I'm left with P equals 795 divided by 53 is $0.15. So that, in context of this problem, is the cost for each pencil, because this is P, is 15 cents. So now I am trying to solve for the cost for each notebook. So I'm going to plug in the P value of 0.15, and I'm going to solve for N. So I'll plug that in here. So I have 5N plus 11 times 0.15 equals 310. And I'm going to multiply 11 times 0.15, and I get 5N plus 165 equals 310. Whoops. I'm going to subtract 165 from both sides. I get 5N equals 310 minus 165 is 145. Divide both sides by 5, and we get N equals $0.29. So to answer this question, what is the cost for each notebook and each pencil? We can say each notebook costs $0.29, and each pencil costs $0.15. And that is it.